So remember, yesterday we figured out that there's 52 choose 5. So if I pick 5 cards here, 1, 2, 3, 4, 5, I make the poker hand. Not bad, not bad. 2 queens. That's homework from the next meeting. The notes are in your note package that you got for permutations. You don't have that one? Okay. There we go. Now I pick 5 random cards, and in my 5 random cards, I happen to get a club. So the question is, how would I find the number of poker hands without clubs? If I wanted to pull out 5 cards from here and guarantee that I didn't get any clubs, does it make sense that the easiest way to do that would be to first go through and if I take out all the clubs, there we go. Take out all the clubs. Oh, wait, you get the idea. And then I pick 5 cards. Will I get a club? No! Amazing! If I take out all the clubs and I pick 5 cards, I won't get a club. That helps us in counting them. If you want to count the number of poker hands without any clubs, you say, well, I take out the clubs, leaving me with 39 cards left. I then choose 5. And I would get all the poker hands that have no clubs. Which, we go to our calculator now and we go 39, choose 5. Again, I can do it on the screen here as well. 39, math, go over to probability, choose 5. Very beautiful number, actually. 57, 57, 57. Part B. Find the number of poker hands with at least 1 club. Okay. And I'm going to do something different in this question than I normally do. Because normally I just show you the right way to do something. And then you hopefully say, okay, I hope to do that later myself. But an interesting thing happens when you try something yourself. Does your brain ever go maybe I should try this, or maybe I should try this? And sometimes you might choose a wrong pathway. It's important for us to develop we have to be critical of ourselves to try to point out when we're making mistakes. So what I'm going to do is I'm actually going to do this 3 different ways, and I'm going to be a salesperson trying to sell you that all 3 of the ways are correct. And your brain has to start to decide, is his explanation good or is there a problem with his explanation? But I'm going to be a salesperson and I am going to make you believe that all 3 are correct. It might be all 3 are wrong. I'm just trying to convince you. Or maybe they all 3 are right. Or maybe only 1 is right and 2 are wrong, or 2. You have to decide. So I will teach you 3 different ways to solve this question. And you have to decipher which one you think are right and which ones you think are wrong. Okay? Number 1. I need a poker hand with at least 1 club. So since I've already taken out the 13 clubs, I'm going to take those 13 clubs, mix them up, and choose 1 of them. Oh, I got a club. Amazing. So if I do that first, 13 choose 1, I've guaranteed that I have 1 club. Then I take the other 12 and I put them back in the deck. I shuffle it up. And I randomly pick 4 more cards. Could I get another club? Does it make sense that I could get another club? Could it be possible I only get the 1 club that I had? Yes, right? So on these 51, see, 1, 2. I chose 4 more cards, and I got all spades. That's really weird. Anyways, I didn't get another club, but I already had at least one. But if I do that next, 51, choose 4, I could get more clubs, but I didn't have to like I did. Have I got at least one club? Yes. That's method 1. Method 2. What I'm going to do in method 2 is I'm going to use the not strategy. Because it says at least one club. What are the bad hands? The bad hands are all of the poker hands that have no clubs. So the not strategy is all minus the bad. And we already counted all the poker hands as 52, choose 5. And in part A, we counted that there was 39, choose 5 without clubs. So if you took all the poker hands and removed the ones without clubs, all the ones that would be left would have at least one club. That's method 2. And method 3, I'm going to break this up into cases. So I'm going to count things, got my 13 clubs, I shouldn't have mixed them up, but I could have my 13 clubs separately, and I'm going to do a bunch of different cases. I'm going to do case 1. Case 1, I'm going to count one club, exactly one club. Maybe I'll even add the word exactly. If I want exactly one club, I have 13 clubs. I choose 1 from my club section, and then from my 39 other cards, I choose 4 more. That would get me exactly one club. Then I could do case 2. Sorry, this one, I don't sell as many of this one because it takes longer than the other methods. But case 2, we're going to do exactly 2 clubs. So then I have my 13 clubs, I choose 2 of them. And then from my other 39 cards, I choose 3. And you probably see a pattern in my cases. What haven't I counted? Exactly 3 clubs. So I have my 13 clubs, I choose 3 of them, and then for my 39 other cards, I choose 2 more. And you see that we're going to have 5 cases. Case 4, exactly 4 clubs, which would be 13, choose 4, and from my 39 other cards, I choose 1. And then case 5, exactly 5 clubs, so I just go for my 13 clubs and I choose 5 of them. Since it's a cases question, I would figure out each of those numbers separately and add them up to get my total. So as a salesperson, here are 3 ways of doing this question, and they are all correct. Trust me. That's what a salesperson is supposed to do. You're supposed to trust me that you should buy all 3 of these products. They're all very good. All right. Did I do a good job? Were they all 3 believable? Now, are they all 3 right? Maybe I was just, maybe all 3 are good. Or maybe all 3 are bad. It'd be so tempting. Can you imagine? Teach a whole unit completely wrong from the very beginning. Do quizzes and tests and everything. And then after all that, like, just kidding. How mad would you be? Just a little bit? Yeah, I don't know. I think I might get in trouble if I did that. Okay, but what we could do is, what could be ways to decide if they're all right or all wrong, or at least possibilities? What could we do? check if the answers are the same. So if we check if the answers are the same, if all three answers are the same, then you know that they're either all three right, or they still could all three be wrong. Okay, so I'm gonna go to my calculator here. I'll calculate number 3 because it's the longest. Would someone calculate number 1 and someone calculate number 2? Okay, the green one is 2, 0, 2, 3. 2, 0, 3. And the black one, what did you get for the black one? You say you got the first one? 3, 9? 3, 2, 4. 8. 7, like that? Okay. Anybody do the blue one?
2, 0, 2, 3, 2, 0, 3.
Ooh. They can't all three be right. Okay. They still could all three be wrong. Or you could have 1 right and 2 wrong, or 2 right and 1 wrong. Okay, now we've got our answers. Our answers actually tell us something. You can decipher something about the wrong one or wrong ones from the answers. Any ideas how you could use your previous knowledge to say that something is wrong? Either that this answer's wrong or this answer's wrong. Any ideas? The hint is in your notes. You should be able to tell me a good reason why something is wrong based on those answers.
We figured out what it. Is it the 39 choose 5? Like we found an answer for that.
Yeah.
And then for the second one, we subtracted that. So it'll have something to do with checking out that answer.
Maybe. There's something in our notes somewhere that we can say, because of this, I know blah, blah, blah is or are wrong. There's about 2.6 million poker hands. 52 choose 5 is all the poker hands that exist in the whole world. 2.6 million. So what's the problem? The first one is more than, so you're like, this has to be wrong because our answer is more than the number that are possible. You can be like, there are 2.6 million poker hands in the world. Of the 2.6 million, 3.2 million of them have at least one club. And then your brain starts to struggle a little bit. It's like, I don't know if you've ever seen people wear, there's like math joke t-shirts. They don't usually go over well in making lots of friends, but you can buy them. And they can be like, 4 out of 3 people don't get fractions. There's like shirts like that. And then if someone says to you, I don't get your shirt, you just pretend you didn't hear that. You just let them be. But yeah. So that's the same idea. You can't have more hands with at least one club than exist in total. The other two are right. one year I should just make 3 different methods that are all wrong. No. But no, the other 2 are right. The not strategy, do you see, is the best. I probably sell a lot more of those than doing this method, but the cases works as well. So the question is, I think I did a good job of selling the black method of choosing at least 1 club and then putting it back in and choosing 4 more. What went wrong? This is the hard part, deciding how come we counted too many. And I can show you this with an example. So in the 13 choose 1, I could choose any of the clubs. Let's say I picked the 7 of clubs, right? And then I put the other cards back in and I picked 4 more cards. The 4 more cards, I could have picked the ace of hearts, the 5 of diamonds, the 6 of diamonds, and also the, I was going to say 12 of, but that's going to be really bad. Let's just go 10 of clubs. That's a possibility, right? In my 13 choose 1, I could choose the 7 of clubs, and then I mix all the other cards, and I could, in the 51 choose 4, pick this. I'll do it again. In the 13 choose 1, I could have picked, oh, the 10 of clubs. And then I mix all the cards back in, and I could have picked the ace of hearts, the 5 of diamonds, the 6 of diamonds, and I hope you can see what's going to be the problem. I could have then picked the 7 of clubs. And in this method, it would have counted that separately. Are those different poker hands? They're exactly the same, but they were counted separately. How many things did we overcount? Oh, just by 1.2 million. You know, right? We were close. No, we weren't actually close. We were off by 1.2 million. But it's an easy thing that your brain could do. Especially when you're counting big things that are hard to visualize, right? Did anybody, when you thought about this question, have a visual of like 2.6 million poker hands and just like you were counting them? No. It's not easy to visualize, especially big numbers. So what went wrong is a combination has no order. We did 2 decisions here. We counted clubs and then we counted other cards. And because there was overlap, you could pick the 7 of clubs here, or you could pick the 7 of clubs here. You created a little bit of order in this question when there shouldn't be. Because these are considered different, because the 10 and the 7 are counted separately. We get away from that problem in the cases because here I choose clubs, here I don't choose clubs. So there's no overlap and I don't add order to the problem. So that's the subtle difference between the cases part and why it works, and this one and why it doesn't. But those are hard things to see. So when you're doing a question, you sort of have to like be critical of yourself. Am I causing a problem here that I don't want to? Do I create overlap? Am I counting things in the same thing in different spaces? Then I create order. If I'm counting different things in different spaces, then the order still won't matter. All right, that is the last question on your booklet. But what we're going to do right now is look at the mathematics between some poker hands. I don't know if you have a blank page at the very end, or you can just on maybe on a blank page in your book. So if you want to turn to page 734. Page 734 of your textbook is empty, and we can write these questions in there. Okay? We're going to list some strategies that we're going to use, and sometimes in math, when you list a strategy, it's very hard to understand until you've done some examples with it. So I'm going to list the strategies first, then we're going to do some examples, and hopefully the strategies make sense after you've seen the example. Okay? Okay, strategy number 1. We're going to choose kinds of the same size at the same time. So when I say kinds, in poker, they sometimes say 3 of a kind. Okay? 3 of a kind has a size of 3 because it has 3 cards. Okay? 2 pairs would have 2 kinds, maybe 2 9s and 2 5s. So you have 2 kinds that are both of size 2. They have to be chosen at the same time. And we'll see that when we do some examples. Next, sometimes people call this the suits. I like to just call it the specific cards of each kind. So what does this look like? And we're not going to do all the poker hands, but we're going to do some. So the first one that we're going to do is a pair. And what we'll do is each time I'll show an example of what a pair is. In poker, you could get a pair of aces. You could have the ace of clubs, the ace of diamonds, wow, and then your other 3 cards have to all be different. So you could have the 7 of clubs, the 3 of spades, and the 5 of hearts. This would be an example of a pair. So you have one kind or 2 things that are the same, and the other 3 have to be different. So the strategy says, choose kinds of the same size at the same time. So for my pair, there are 13 different kinds or numbers. I think they use the word kind in poker because a queen really isn't a number. So we say, okay, the different kinds of cards are ace through king. There's 13 different ones of those. We need to choose one of them to be our pair. We could have a pair of aces, we could have a pair of 10s, we could have a pair of anything. Then, part 2, once you've chosen your kind, you have to choose the specific cards. So if I chose aces, how many aces are in a deck of cards? There's 4. Which 2 aces do I have is for choose 2. Sometimes people say this is choosing which suits your aces are going to be. I just think I have my actual 4 aces. Once I've chosen that my kind is going to be aces, I take out the 4 aces. Which specific 2 cards am I going to pick for choose 2? This together counts all possible pairs.
Can I steal a few more whiteboard markers?
Yeah.
Got a big class right now. Thanks.
That's all the possible pairs that exist. What do we have to go with that pair? We need to pick 3 different cards. Again, we want to make sure there's no overlap. So now, does it make sense that you've used up, in our example, the aces, there would be 12 kinds left. We have to choose 3 single cards. We have to choose those at the same time. That's what this first choose kinds of the same size at the same time. So we go 12, choose 3 to choose, in our example, a 7, a 3, and a 5. Then we have to choose the specific cards. If I chose 7s, how many 7s are there in the deck? There's 4. I need to choose which specific 7, which specific 3, and which specific 5. That would pick 3 single cards that are all different. So if we choose the kind first, and then the specific cards after, and we always choose kinds of the same size at the same time. You could have done this by doing your 3 single cards first. You could have started with 13, choose 3, 4, choose 1, 4, choose 1, 4, choose 1, and then done how many cards are left after taking 3 out, 10, choose 1, and pick your pair after that. That's still fine. Notice that there's no overlap in anything that we've done. That's important for counting poker hands. And we should, I should have this written out somewhere so that I have the numbers ready for you. There we go. I'll figure it out. I'll figure them out and put them up after. Number 2. A better hand in poker would be 2 pairs. An example of 2 pairs, 2 cards that are the same, 3 of clubs and the 3 of spades, and another 2 cards that are the same, 5 of hearts and 5 of clubs, and then 1 card that is different, maybe the ace of diamonds. That would be an example of having 2 pairs. If we wanted to count this, sorry, I figured out this first number. The first number here is 1,098,240 out of the 2.6 million. So you have just a little bit less than, if I give you 5 cards at random, you have a little bit less than a 50% chance of getting a pair. Okay? If we're counting 2 pairs, do you see that those are the same size? They have 2 cards and 2 cards. We have to choose those at the same time. So we have 13 cards, or 13 different kinds. We choose 2 of them to be our pairs. Chose 3s and 5s. There are 4 3s in my deck. I choose which 2 specific 3s I want. 4 5s in my deck. Choose which specific 2 5s. This all together will count all possible 2 pairs. What has to go with this? We have to pick 1 more card. Okay? For this 1 more card, I'm going to keep with the same method. How many kinds are left? We've used up 2 of them. There would be 11 kinds left. We choose which one? I picked aces. How many aces are there? 4 aces. I choose 1. This gives me a single card. But if you wanted a single card, does it make sense that you could have just put that together as there's 44 cards left in the deck? After taking out all of the 3s and all of the 5s, because that's 8 cards. If I took those out, there'd be 44 cards left, and I just need to choose 1 of them. I wouldn't have had to do kind first and specific card second, because I'm just choosing one card. But I kept with the same method here. And if we type this into our calculator, we get 123. Which is not quite 10 times, but maybe like 9 times better. So if you're playing poker and you've got a pair and you think you have a good hand, and later you play and you've got 2 pairs, you have to realize your hand is now 9 times better than that person that has a single pair. It's quite a bit better. For me, the thing in poker when I first started playing was, how is it that 3 of a kind is better than 2 pairs? Why is that? Like, you know it is because they give you the list of what's better, but mathematically this is going to show why 3 of a kind is better than 2 pairs. And we can show that mathematically by showing there's less of them. And each of these, we could take this 123,000 and divide it by the 2.6 million poker hands and figure out that your chances of getting this is like 5%, about 1 in 20. So if I dealt out 20 hands, one of those 20 hands should have 2 pairs, theoretically. 3 of a kind looks like this. You have 3 of one number. Let's say I have 3 hearts, and my other 2 cards have to be different. This would be an example of 3 of a kind. Notice that these sizes are the same. We have 2 single cards. So first of all, of the 13 kinds in the deck, I have to choose one of them to be my 3 of a kind. I happen to choose 7s. Then my specific 7s, there are 4 of them, I choose 3. This will give all the possible 3 of a kinds that could exist. Now for our last 2 cards, they're the same size, so we choose them at the same time. There's 12 kinds left. We choose 2 of them. I chose aces and 5s. 4 choose 1 and 4 choose 1. This will choose 2 single cards that are different. So in this case, we couldn't do 48 choose 2 because we might get 2 that are the same. And there's only 54,000 of these compared to the 123,000 2 pairs. So it's not as big of a jump from the single pair. This is still almost like just a little bit more than twice as unlikely. Probably got about a 1 in 40 chance instead of a 1 in 20 chance. So it's a really good hand if you get 3 of a kind. And then we can have some fun. Have you ever heard of a full house in poker? For those of you that have never played poker, I hope you're at least learning something as we go along. A full house would be very similar to 3 of a kind, but then your last 2 cards are also the same. So that would look like 8 of clubs, 8 of spades, 8 of hearts, 3 of hearts, and 3 of diamonds. So you have 3 of one kind and 2 of another kind. This is actually going to be really easy with our method to count. We have no kinds of the same size. Is it different if you had 3 8s and 2 3s compared to 3 3s and 2 8s? Yes. Right? So we have to choose the kinds separately. So for our 3 of a kind, there's 13 different kinds. We choose one. We chose 8s. Then there are 4 8s. We choose which 3. This will count all of the 3 of a kinds possible. Next, we have 12 kinds left. We choose one of them to be our pair. And I chose 3. There's 4 3s in the deck. I choose which specific 2 cards I want. This will count all the pairs that could go with my 8s. Multiplying all of those together. And when typing things into your calculator, as many combinations as you can do in your head is way faster than getting to the button. So what I would do is I like 13 choose 1. Can you see that that's 13? 4 choose 3 is the same as 4 choose 1. That's going to be 4. 13 times 4, 12 choose 1, that's 12. 4 choose 2, that one you might have to type in, or if you know it, it's 6. Then perfect. So it's just going to be 13 times 4 times 12 times 6. And when this happens to you in poker and you get that full house, it is so rare. Right? You've got about a 1 in 1,000. Actually, 106.94. So you could deal out 694 different hands, and your chances of getting it would only happen that few times. Now, some of you play different versions of poker. Probably the most famous one that's online and on TV is Texas Hold'em. That's where you get 2 cards, and they put 5 cards out in front of you. And you use your 2 cards and the 5 cards to make the best 5 hand you can have. The reason it's so popular is because 7 cards are out there, your chances of getting these better hands happen more often. And so it adds more excitement when better hands happen more often. If you just got regular poker where you got 5 cards and could look at them, most of the time a pair would win. Because you don't get to do much to change it. So there's different styles of playing poker. One of the reasons that one's so popular is you can get better hands more often, and you also have a better idea of what the other person has. So there seems to be more bluffing and more decision making, which makes it a little bit more fun. So that's the main ones that we can do. I mean, a royal flush, there's only 4 of them. There is 1 in hearts, 1 in spades, 1 in clubs, 1 in diamonds. So when you get that, there's only 4 out of the 2.6 million poker hands. That obviously makes it the very best possible. So, other things are a little bit there. This is how to count your main hands. There's also like, how do you count a flush? A flush is actually a cases question. So, and the cases are all exactly the same. I'll just show you one case. Let's say we want to get a flush in hearts. It would be 13 choose 5. Okay? The problem with the 13 choose 5 is it would also count the straight flushes, which in poker are even better. So you have to do 13 choose 5 and then subtract You could have a straight flush of ace through 5, 2 through 6, 3 through 7, 4 through 8, 5 through 9, 6 through 10, 7 to jack, 8 to queen, 9 to king, and 10 to ace. We just counted all straight flushes and the royal flush. There's 10 of them. Ace to 5 all the way up to 10 through ace. So in flushes in poker, they would take out those 10. Can you see that whatever this number is, the clubs case is exactly the same, the spades case is exactly the same, the diamonds case is exactly the same. So we could just take this and times it by 4, and you would get how many in total would be your flushes. And, oh, now I'm curious on the number. $5,108. Super rare. And I have played games where I have that flush and I think, oh, I'm going to win, and somebody has the full house and they win. And then there's some certain specialized poker words that you say after that when you lose a hand like that. Well, they might be just words you say normally. Yeah, it's like, oh, you thought you had it is such a good hand. The flush is super rare. It happens quite a bit, though, in Texas Hold'em because of the extra cards. It would be super rare if you just got 5, but getting those extra 2 cards makes flushes happen more often, or even though they're super rare. So, I hope you found that interesting in seeing the mathematics behind how poker hands are decided, which one's better, which one's worse. There's straights are another strategy of trying to figure out how to count them and which ones are in there. But you can look all those up online to figure them out. So everybody should have the homework as well for combinations 1 and combinations 2. We handed that out last class. You can start working on that. We might do some whiteboards on those questions maybe on Thursday. Tomorrow I'm gone in the morning, and the next thing in